recording. All right, so we have 1/2 plus 2 over x plus 4 divided by 6. So this is a horizontal. Sorry, this is vertical. We can turn it horizontally to make it look like a little bit less intimidating. So in that case, it would be 1/3 plus 2 over x divided by x plus 4 over 6, right? So in this way, you can better see the denominators inside. The denominators are the fractions inside the big fraction. And what we want to do is get rid of those denominators. So to get rid of the denominators, you want to find one term that 3x and 6x will all go into evenly, right? And then you're going to multiply everything by whatever that term is. Good? All right. So 3 and x would be something like 3x. 6 and 3 and x would be something like 6x, right? Because 6 multiplied by 6x, the 6 goes into the 6x, the 3 goes into the 6x and becomes a 2x, right? So we're going to multiply everything by 6x. When you have, so when you're multiplying by it, it goes up to the top, right? So now I have a 6x on the top, a 3 on the bottom. Here I have a 6x on the top, an x on the bottom. Here I have six x on the top, 6 on the bottom. Good. I can also rewrite this as 6x times 1 is just 6x. 6x times 2 is 12, right? X. And then I can distribute that 6x. 6x times x is 6x squared. 6x times 4 is just, right? Yeah. (24x over 6). Good. Now I can divide 6x divided by 3. So this is like the longest way to do it. If you know a faster way, that's fine. 6x divided by 3. 6 divided by 3 is just 2. So that becomes 2x. 12x divided by x just becomes 12 because x divided by x cancels out. Divided by 6x squared divided by 6 is just x squared. And then 24x divided by 6 is just 4x. Sorry. So now that's 2x plus 12 over x squared plus 4x. Again, we were practicing putting it into the most factored form. So 2x and 12, I can divide them both by 2. So I could take out a 2 and just leave it as x plus 6. Here I can take out an x and it can be x plus 4. Any questions? So that was that first example. No problem. Now we have 1 minus x over x plus 1 divided by 2 minus x minus 1 over x. So again, here we looked at 3x and 6 and decided that the way, like the one term that they all go into is 6x. Here, it's going to be just those two denominators. So I'm going to take both of those denominators and multiply them by 1, by x over x plus 1, by 2, and by x minus 1 over x. Good? So we're multiplying everything by x times x plus 1. Multiplying everything over here by x times x plus 1. So that's now 1 times x plus 1 minus x times x plus 1. Let me know if you don't like how I'm writing it. Over x plus 1, right? Divided by 2 times x plus 1. Well, I don't like how I'm writing it because that was a mistake. So that 1, I just left the 1 off. We're just multiplying the 1 times the x plus 1. So I just wrote x times x plus 1. Here we're multiplying 2 by x times x plus 1 minus x minus 1 times x plus 1 over x. Good. And make sure, because this is subtraction, we don't want to get confused. I'm subtracting all of that. All right, before you start, what would it be, distributing? I want you to cancel. So the reason that we multiplied it all by x times x plus 1 is so we could cancel out the x plus 1 here. And so we could cancel out the x here. Okay. So now you can call that x times x becomes x squared. X times 1 is x. Good. Minus x times x, right? Because that's all canceled. Divided by 2x squared plus 2. Any questions? I just distributed the 2x to the x plus 1 minus x minus 1 times x plus 1, right? Because I'm subtracting all of it. So x times x is just x squared. So that's x squared plus x minus x squared divided by 2x squared plus 2. Ooh, sorry, x. X times x becomes x squared. X times a positive 1 is just x. Negative x minus 1, if I was to FOIL that. So x squared plus x minus x squared just becomes x, because we're taking a positive x squared and then we're subtracting 1x squared. This is still 2x squared plus 2x minus, these two cancel, x squared, and I'm going to say plus 1 because we're distributing that negative. X on the top. The 2x squared minus x squared just becomes x squared plus 2x plus 1. X squared plus 2x plus 1 is also x plus 1 squared. Again, this is not showing up on the exam. I know that was a lot. Dawson, thank you. You got that way before me, didn't you? Sorry, I didn't see you. Must have been looking down. Nice save. All right. So work on that. If you have questions, come Friday. Radicals and rational exponents. So what is a radical? It is the inverse of an exponent, right? Just like to add is the opposite of subtract, multiply is divide. This is the opposite of this. Good. So here, when we say the third root of 64, what they're asking is, what number raised to the third power gives me 64? So 64 is a number times itself 3 times. You can either look for it on your, or sorry, just put it into your calculator, or you can kind of like play around with your calculator to multiply a number 3 times. Or you can look it up on Google, the cubed roots, and it'll just start a list. Good. So 64 is 4 times 4 times 4. So the cubed root of 64 is 4. Because 4 times 4 times 4 is also 4 to the third power. The cubed root of 4 cubed is 4. It's undoing this. This undoes this. So here we have the cubed root of -8. Same question. What number do I multiply by itself? Oh, sorry. I'm going to write lines. 3 times to get -8. 2 times 2 times 2 is +8, right? And -2 times -2 is a +4. But if I then take that +4 and multiply it by a -2, I get -8. So the cubed root of -8 is -2. You'll never see the square root of a negative number. The square root of -4 is not a real number. But if it's the third root, it is possible. It'll just be a negative number every single time. Good. All right, for example C, what you want to do when you have a fraction is you can take that fourth root and you can distribute it. So now you can take the fourth root of 1 over the fourth root of 81. What can I multiply by itself 4 times to get 1? Just the number 1. Okay. And if you don't have on a TI calculator, you can go to math. Oh, sorry, you should write it first. So I want to take the fourth root. So I put in the number 4, go to math, and that fifth, and it puts the 4 up there. So the fourth root of 1 is 1. The fourth root of 81 is 3. Or I can just say the 2 to the fourth power is 16, and just kind of like go one number at a time if you want, or like that, right? So 81 is just 3 times 3 times 3 times 3. So our answer is 1 on top, 3 on the bottom, or 1/3. Good. Here I said the third root of 4 to the third power is 4. The sixth root of -4 to the sixth power should be -4, shouldn't it? But if it's an even root, this can never be negative. Okay? So think about it. -4 6 times. It's only halfway there. 5, 1, 2, 3, 4. That becomes a positive, 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 right? So those all become positives when you multiply them in pairs, right? 4 times -4 is going to be a positive 16. This one's going to be a positive 16 that we multiply together. And this one's going to be a positive 16. So if you have a negative number under an even root, the answer is going to be become positive. Four to the sixth power is 4096, and -4 to the sixth power is that same number. So even if you put the -4 under there, -4 to the sixth, it comes back positive. So the sixth root of -4 to the sixth is a positive 4. -4 to the sixth is a positive number. And then the sixth root of that positive number is also a positive number. All right, moving on to the properties of radicals. And I would just add this. This is what I would have on my Unit R note card. I would have the difference of two squares, the sum of two cubes, the difference of two cubes, and then I would include properties of radicals and properties of exponents. So our properties of radicals are the roots and the exponents are inverse. So if they match and the n is odd, the answer will be the original number. So the nth root of a to the nth power is just a. The nth root of a to the nth power is positive a if n is an even number. Okay, so if you ever see this happening, it's going to be positive. The answer is going to be positive. If you have a, b, you can separate them and put them both under the radical n. The nth root of ab is the same as the nth root of a times the nth root of b. Just like we did that with that 1 over 81, the nth root of a over b is the same as the nth root of a over the nth root of b. And you can put the exponent outside of the radical if you want. So the nth root of a to the power of m is the same as the nth power of a all raised to the power of m. Good. All right, so for these examples, what you want to do with these numbers is break them into their prime factorizations. So 50, you're just going to say, what can I divide 50 by? And you turn it into a Christmas tree. 50 is 2 times 25. Good. 2, there are no factors of 2 except for 2 and 1, but 25 can be 5 and 5, right? 2 times 25 is still 50, so each layer of the Christmas tree still equals 50 when you multiply it. It still equals the original number up here, but you want to get it into these small numbers because you're trying to find If this is an understood 2, that means if any number is multiplied by itself 1 time or 2 times, it comes out. So the square root of 50 is the same as the square root of 2 times 5 times 5, and the square root of 5 times 5 is 5. And you can check that. The square root of 50 is the same as 5 square root 2. That's because that's an understood 2, so you're looking for a pair of numbers. Here, it's a 3. If there's no number here, it's always 2. So this one's a 3. So I'm going to take 54, make a factor tree. 54 is 9 and 6. 6 can factor to 3 times 2. 9 can factor to 3 times 3, right? And each layer of the factor tree, 9 times 6 is still 54. I'm just making the factors of 54. 3 times 3 times 3 times 2 is still 54. Good. So the cubed root of 54 is the same as the cubed root of 3 times 3 times 3 times 2. Because this is 3, I need 3 of the same number. So the cubed root of 54 is same as 3 times the cubed root of 2. C has a negative number under the radical, but as long as that radical is not a 2 or not an even number, sorry, it is okay. We can find the answer. If this is odd, this can be negative. So negative 24. 24 is 6 times 4, right? 6 is 3 times 2. And 4 is 2 times 2. And I'm looking for groups of 3. So I have a group of 3 2s. And then I can take my x separately. I just look at them as x. X to the 5th is 5 x's. Good. So we have got cubed root of negative 24 is the same as the cubed root of negative all of this, right? 3 times 2 times 2 times 2 times 5 x's. This can go out in front. So now I have 2x times the cubed root of negative 3x squared. All right, for D, I have the 4th root of 81, x to the 6th. The 4th root of 81, we kind of already saw it, right? The 4th root of 81 is 3. And then the 4th root of x to the 6th. So there's 6 of them. I can take out 4 to become 1. So that's 3x. And then the 4th root still has an x squared inside it. And then the 4th root of 256. So you can just say, what's 3 to the 4th? It's not that. What's 4 to the 4th? Oops, sorry. 4 to the 4th. If your calculator doesn't do it. 4 to the 4th is 256. Or again, Google it. Don't hesitate to Google it. So that's just the number 4. So if you put it in your calculator, you get a decimal back, then break them down using a factor tree until you find the prime numbers. See if you can pull any of the prime numbers out. It does not matter whether you made this 2 a negative or this 3 a negative. You could put that's okay too. You can put the negative all the way out in front, or you can leave it under the radical. All right, combining like radicals. When simplifying, combine like radicals. Radicals with the same index and the same radicand. So you want this. Here is the index. The index is this number. And then this is the radicand. You can also call the index the root. Good. So these have an index of 2, but they do not have the same radicand. They want us to combine them. So in order to do that, we can take 20 and divide it by obviously 5, right? Because we need a 5 to be under there. 20 divided by 5 is 4. 4 becomes 2 and 2. So the square root of 20 is the same as the square root of 2 times 2 times 5, which becomes 2 square root 5. This -4 comes down and we multiply it with the square root of 20, which we change to 2 square root of 5. So these just stayed the same. Sorry, that's not 5, it's square root of 5. -4 times a positive 2 becomes -8. Now we have the same index of 2 and the same radicand of 5. -8 plus, not 5, just -8 plus 1, right? There's just 1 square root of 5 here. -8 plus 1 is -7. We have combined like radicals. Here we have an index of 3 on each one. Here the radicand is x, here it's -x, and here it's x, or sorry, here it's 8x, here it's -x, and here it's 64x to the 4th. Good. All right. So if I have 3, 8 times the third root of 8x, 8, don't worry about the x, 8 becomes 4 and 2, or I just know it, right? 4 becomes 2 and 2, 2 stays the same. So 3 times the third power of, sorry, the third radical of 8x becomes 3. The third root of 2 times 2 times 2 times x. These 3 can come out. So now I have 3 times 2, and then that x is still inside. Good. Plus 5 Since I clearly want them to have the same radicand, I'm just going to take out the negative. So that becomes negative 5 cubed root x. Now I have the same radicand. So instead of adding 5 times negative x, I'm just going to say minus 5. And then we have 64 x to the 4. You need to make a factor tree. 64 becomes 8 and 8. 8 becomes 4 and 2. So we can't take those two 8s because we need 3 because it's the third root. Good. But 4 becomes 2 and 2. This 2 comes down. This 4 also becomes 2 and 2. This 2 comes down. So the third root of 64 is and then, sorry, I ran out of room. I would have put these all under 1. And then 4 x's, right? So what can we take out? We can take out this 2 and this 2 and these x's, and we are left with the cubed root of x. Or you just know that the cubed root of 64 is 4. That's also fine. Let's bring each of these down. 3 times 2 becomes 6. Cubed root x minus 5 cubed root x plus 4x cubed root x. 6 minus 5 just becomes, sorry, cubed root x. And then we can't combine it with 4x because 4x is not like terms with 5 and 6. So that's the final answer. All right, rationalizing the denominator. When combining like radicals, it is improper to leave the radicals in the denominator, so we rationalize the denominator. Here I have 2 over the square root of 3. I want to rid the denominator of the radical. If I have the square root of 3 and I multiply it by the square root of 3, what happens? It just becomes 3. Anything I do to the bottom, I also have to do to the top. The square root of 3 times the square root of 3 is the same as the square root of 3 times 3, right? And again, if this is, if the index is 2, we just need 2 numbers that are the same, so they come out. So that's 3 on the bottom, 2 square root of 3 on the top. That's all you need to do because you can leave radicals in the numerator. So I multiply that bottom term by itself. But if I do it to the top and the bottom, it's like multiplying something by 1, right? Because square root of 3 over square root of 3 is just the number 1. You can also check it in your calculator. 2 divided by the square root of 3 is going to be the same as 2 square root of 3 divided by 3. Oops. Same number. Good. For B, you don't need to multiply by 5 square root of 2. We are only worried about the square root of 2. So we just want to make the square root of 2 into a perfect square under the radical, right? A perfect square under the radical would be 4 And just like here, 9 is a perfect square, 4 is a perfect square, so that becomes 5 times 2, and then it stays 3 square root of 2. 3 square root of 2 over 10. All right, rational exponents. If a is a real number and n is an integer greater than or equal to 2, then the rules are just like the rules of exponents, right? Oh, not really. All right, a is 1 over n is the same as that root of a. If a is the power of m over n, then that top number becomes your exponent, that bottom number becomes your index. And you can put that exponent outside of the entire thing if you want. Good. So the top number is the exponent, the bottom number is the root. Exponent over the root when you rewrite it, or the index, the exponent over the index. So 9 to the power of 1/2. What does that look like? Sorry. 3. Why? Because the top number is your exponent, so it's 9 to the first power. That second number is your index. So the square root of 9 is 3. -8 to the 1/3 is, it's still -8. The top number is your exponent, the bottom number is your index. The third root of -8 is -2, right? Because -2 times -2 times -2 is -8. -12 to 1/2. The 2 goes here, the 1 goes here. So the square root of 12 is the same as the square root of 3 times 2 times 2, which is 2 square root of 3. All right. Oh, sorry. All right. 54 to the power of 1/3 becomes 54. The third root of 54. 54, if we're going to make a factor tree, becomes 9 and 6. 9 becomes 3 times 3. 6 becomes 3 times 2. And the third root, so I can take all of those 3's out. So the third root of 54 becomes the third root, 3 times the third root of 2, right? Because all 3 of these can come out. So here we had 9 to the power of 1 over 2. Here's 9 to the power of 3 over 2. The way that changes the 9 is the index is still a 2, the base is still a 9, but instead of 9 to the first power, we now have 9 to the third power. Good? So remember, exponent over index or exponent over root. So you can take 9 to the third and take the square root of it, or this rule says we can take the square root of 9 and raise it to the third power. We know that the square root of 9 is 3. 3 to the third power is 27, right? All right. The next one is a negative 27 to the 4/3 power. So my index is 3, my base is negative 27, and I'm raising it to the 4th power. Good? So again, I can take the third root of negative 27 and raise it to the 4th. I know that negative 3 times negative 3 times negative 3 is going to give me negative 27. So I know that's negative 3 to the 4th, and negative 3 to the 4th is a positive 81, because negative times a negative is a positive, negative times a negative is a positive. 32 to the negative 3/5 becomes 32 is still my base. That bottom number is my index. The top number is my exponent. So we're raising 32 to the negative third, and then we're taking it the 5th root of that number. What is the 5th root of 32? Let's just see if it's perfect. The 5th root of 32 is 2. So all of that becomes 2. 2 to the negative third is the same as moving the 2 below the fraction bar, raising it to the third power. 2 to the third power is 8. So 32 to the power of negative 3/5 is 1 over 2 to the third, or 1 over 8. 16 to the power of 12 over 8 is, let's reduce 12 over 8. 12 and 8, I can divide them both by 4, right? 12 divided by 4, 8 divided by 4. I get 3/2. So 16 to the power of 12 over 8 is the same as 16 to the power of 3/2. A little bit easier now. So my index is 2, my base is 16, my exponent is 3. The square root of 16 is 4, right? And 4 to the third is 64. So for example 6, it asks us to simplify each expression and express the answer so only positive exponents occur. Assume that variables are positive. So what we want to do is we want to rewrite each of these. Right now we are taking x times y, raising it to the 1/2, times, now I have to distribute that 2/3. Negative 3 times 2/3. Negative 3 times 2/3. Are we comfortable with that? Negative 3 over 1 times 2 over 3 becomes negative 6/3, which is negative 2. 2/3 of 3 is 2. Good. But it was a -3, so it's a -2. So that's y to the -2nd power. Good. Now remember, when you are combining exponents, if the base is the same, you can just add the exponents. So this is a 1, 1/2, 2/3, -2. So the base needs to be the same, and I can add the exponents. So here I have x to the power of 1 and x to the power of 2/3. Here I have, y to the power of 1/2 and y to the power of -2. Is that okay? All right, how do I change this into something I can add? Well, 1 and 2/3. If I want to combine those, I need them to be the same base, right, for fractions. 1 is the same as, I want the base to be a 3. 1 is the same as 3 divided by 3, right? 3 divided by 3 is 1. So instead of 1 plus 2/3, I can call that 3/3 plus 2/3, which is 5/3. And you can do that for the same, you can do that same trick to the number 2. Good, so we have 1/2 minus, and I want these to be in 2. Instead of 2/2, it's going to be -4/2, right? Because 4 divided by 2 is 2. Oh, sorry. So 1 plus 2/3 becomes 5/3. 1/2 minus 4/2 is -3/2. So now we have x to the 5/3 times y to the -3/2. Good. Our next one was 3x to the power of 1/2 over y to the power of 3/2, all multiplied by -2. So I'm going to take that -2 exponent, I'm going to give it to the 3, give it to the x, and give it to the y. So that becomes 3 to the power of -2. X, remember, it's 1/2 times -2. You can't add them because you're actually raising it to that power. Over y to the 3/2 times -2. When we're multiplying fractions, you just multiply straight across. So I want to turn that -2 into a fraction, put it over 1. Okay, so 3 to the power, let's leave it alone. 3 to the power of -2. X, let's multiply this. 1 times -2 is -2. 2 times 1 is 2. Y, 3 times -2 is -6. 2 times 1 is 2. Simplify those fractions. 3 to the power of -2 times x, -2/2 is -1. Y, -6 divided by 2 is a -3. Is that okay? So I have 3 to the -2, x to the -1, y to the -3, and only positive exponents are allowed to occur. So I'm going to take that, move it down. Take that, move it down, take that, move it up. So I'm flipping all of them, because if you flip them, the negative exponent becomes a positive exponent. All you need to do is flip it. -1 becomes a 1. I don't really need to write 1, right? So it becomes y to the 3rd over 9, right? Mm-mm. Forgot the X. Sorry. All right, last one. 8x squared y to the 1/2 over x to the 1/2 y to the power of 1/3. I'm going to distribute that 1/3 to everything. So that becomes 8 to the 1/3 x to the 2 over 1 times 1 over 3, right? Y 1 over 2 times 1 over 3 x 1 over 2 times 1 over 3 y 1 over 3 alone. Okay. Leave that alone. 8 to the 1/3 x to the 2/3 y to the 1/6 over x to the 1/6 y to the 1/3, right? We now subtract exponents from the numerator from the exponents from the denominator. Good? So that becomes 8 1/3 x 2/3 minus 1/6 y 1/6 minus 1/3. Good. If we're adding or subtracting, we need them to have a common denominator. So 2/3 minus 1/6. I need to multiply both of these by 2 so that they have a common denominator. 2/3 becomes 4/6 minus 1/6 is 3/6 or 1/2. Here we have 1/6 minus 1/3. Again, I need to multiply this side by 2 to get a common denominator. So that is now 1/6 minus 2/6, which is negative 1/6. And that's for the y. Good. So now we have 8 to the power of 1/3 x to the power of 1/2 y to the power of negative 1/6, right? Okay, because this is negative, I'm going to put it below the fraction bar, even though I know there's no fraction. So I'm going to make a fraction. So it's 8 to the 1/3 x to the 1/2 over y to the 1/6. And now I'm going to change this, all right, based on the rules. So I know that this is the exponent, this is the index, exponent, index, right? So I have 8, the third root of 8 times the second root of x over the sixth root of y. The third root of 8 is 2, but you can just call it 2 square root of x over the sixth root of y.